Every review you're about to watch about the RTX 4060 today is going to tell you that it sucks, that nVidia is price gouging their budget cards, they don't care about you, and you're better off not buying any brand new card right now. And they're not wrong, but they're also not entirely correct, and I think it's time we reevaluate how graphics cards are reviewed. Buckle up, this one's probably going to get good. Welcome back to Craft Computing, everyone. As always, I'm Jeff. I've always had a little bit of a different strategy when it comes to reviewing hardware on this channel. Raw, unadulterated power is not really my ultimate goal, and for the majority of PC gamers, that also rings true. While I get just as excited about the prospect of 4K Ultra, all the settings, ray trace, 240 Hz, face-melting goodness, that's also not what's expected out of a $300 graphics card. So why are we testing them with those settings? I've said this next statement a couple times on Talking Heads, but I don't think it's ever made it into one of my main videos. I have a massive amount of respect for teams at Gamers Nexus, Hardware Unboxed, Linus Tech Tips, Jay's 2 Cents, Pulse Hardware. Rip Bitwit. But I also feel they're only doing part of their jobs when it comes to reviewing the latest hardware, especially when it comes to the more budget-friendly offerings. Now, before you yell at me, we're going to come full circle on this, so don't go anywhere. Every review of the RTX 4060 that you're going to see today is likely performed on their standardized test benches. My guess is the majority of these setups are going to be configured with the latest and greatest hardware running either an Intel 13900KF or maybe a 7900X3D. 32 gigs of DDR5 at roughly 6000 MTS, massive CPU coolers, open test benches to maximize airflow, all in an effort to minimize CPU bottlenecks, eliminate variables, and give you, the consumer, the best picture of where the RTX 4060 lands in NVIDIA's product stack and how it matches up with offerings from AMD and Intel. And I have absolutely nothing wrong with this methodology. It's extraordinarily sound, especially if you're compiling a comprehensive performance chart with 50 different graphics cards across multiple generations. In the end, every reviewer, though, is going to agree that the RTX 4060 is one of the worst value propositions from NVIDIA in a long time, as its performance pales in comparison to the top-flight offerings, has smaller memory buses than the previous generation card, and should all around be avoided. So, where do I think reviewers are going wrong? Well, no one who is looking to purchase a $300 graphics card is going to be placing it into a machine that will run you $2,500. For God's sakes, the test bench that I mentioned has a power supply that costs more than the RTX 4060, let alone the CPU and RAM combo approaching at least $1,000 on its own, paired with the latest $500 motherboard to boot. If you're someone who's on maybe an $800 budget, do the numbers from a test bench with an $800 CPU matter to you when it comes to performance? Not in the slightest. In fact, there have been times when pairing lower-end CPUs or memory configurations completely flips the script on which card becomes the better value, and vice versa for CPUs for that matter. Just because you're able to put every single PC component on a quarter-mile drag strip and wind up with definitive raw power performance numbers at the end of the day doesn't mean that those are the only numbers that matter. Typical GPU benchmarks run all games at 100% max settings, making sure that each GPU gets a thorough workout to accentuate any potential shortfalls when comparing them with higher-end cards. So while you might be eliminating bottlenecks with this methodology, every test also just becomes about how much worse this GPU is than the current flagship, not necessarily about what the consumer experience will be with the GPU in their system. Things like maybe toning down the settings a few notches to get the most performance and frame rate out of their substandard hardware aren't even considered in the review process. And there's another subject that's never touched on outside of dedicated videos on this subject, and that's DLSS or FSR and their roles in modern gaming. Most reviewers won't test with them enabled because there's no objective way to measure performance differences between multiple cards, or even multiple runs of the same game, as they're designed to be able to dynamically change the quality of the game on the fly. But ignoring that these exist in favor of only testing rasterization because that's what you can measure tells the consumer absolutely nothing about what they can expect if they decide to play Jedi Survivor or Spiderman Remastered. We shouldn't pretend these features don't exist just because we can't slap a number on their performance. A lot has also been made about the 8GB bottleneck for 1080p gaming, and if it's not already here, it's certainly coming soon. But again, this only applies to running games at their absolute ultimate settings, and with modern textures and all these ray-traced bells and whistles, there's a lot of data to keep in VRAM. As a reviewer, I feel that my job should be in part to give a full picture of performance top to bottom in both the current lineup of parts as well as the last couple of generations. But a GPU review should also be applicable to the people who are actually in that budget range for that GPU. While there's a lot to be learned about industry trends from top to bottom performance charts with no performance variables, they also do a poor job of telling you which $300 GPU you should spend your money on. And no, I don't think just buy a used card or grab a fire sale 6700 XT is a good enough answer. More on that near the bottom of this video. So what is my computer of choice for testing the RTX 4060 from PNY today? We've got a Gigabyte A520 motherboard mated to a Ryzen 5600G CPU, along with 16 gigabytes of Guile Orion DDR4 3200 memory and a 2TB Western Digital Black SN770 Gen 4 NVMe drive. The price for that combo? $379, brand new today. Add in an ITX case and a 500-watt SFX power supply, you're looking anywhere from $510 on the low end to $679 for the setup that I have here in the Fractal Design Terra, although this case is likely well outside the price range for this review. It also really has no impact on performance, and I'll have affiliate links for both build options down in the video description if you're interested in small form factor PCs. At $510, along with either the AMD RX 7600 or the nVidia RTX 4060, it lands you squarely in that $800 budget that I mentioned earlier. And shockingly enough, that's exactly what we're going to be testing today. If you built this exact PC, which graphics card would you choose for the remaining $300 of your budget? The RX 7600 or the RTX 4060? So, with that 10 minutes of your life that you'll never get back well and truly gone, for those of you who are still with me and haven't sent hate mail already, let's dive into some games. Each game will be tested at the same settings for each GPU, but they will not be set to maximum, as I don't expect an $800 PC to game at 4K 240Hz, and neither should you. I'm going to be testing exclusively at 1440p, and I know that's going to be a bit of a controversial choice as well. I'm making all kinds of them in this video. But the fact that you can buy a 1440p 144Hz panel at about $170 and sometimes even lower on sale means that I honestly believe 1080p is on its way out when it comes to gaming, given the price of entry for higher resolutions now being so low. And, as you'll see, not expecting ultra settings in every game might make you feel the same way too. But what do games actually look like on our $800 PC and $170 monitor? Let's take a look. Finally. Representing the all-new RTX 4060 today is the Accelerate RTX 4060 8GB from PNY, featuring their triple fan heatsink, which fits neatly into a 2-slot space. And thanks to PNY for sending out this unit for my review. We'll be using the press drivers, which are version 536.20 as of the time of testing. For Team Red, I've got the XFX Speedster Swift RX 7600, also with 8GB of video memory. Compared to the Accelerate from PNY, this card is slightly shorter, but also a bit taller, sitting nearly 1.5 inches above the PCI bracket. Not that that should impact your case choice much, as I can't remember any modern PC case having only enough room for that PC bracket. In Doom Eternal, I ran both cards at the Ultra preset, which is Doom's way of saying medium. Here we see the RTX 4060 pull out the win with an average of 188 frames per second and a low of just 108. The RX 7600 also scored impressively well, averaging 166 FPS, although I would like to see the lows do a bit better than 73. While DLSS is available for this title, I opted not to enable it, as both GPUs had no trouble averaging well above the 144 FPS mark. No need to fake it when you're already acing your first test. Project Cars 3 is one of the few titles on today's list without any available AI graphics aids, so we'll have to do this one the good old-fashioned rasterized way. And for the record, if performance is within 5% on any title today, I'm just going to count that as a tie. While human perception can easily spot the difference between 90 and 120 FPS, even superhumans have a difficult time distinguishing sub-millisecond differences. And that's exactly what we have here. At 140 FPS, the RTX 4060 is exactly 5% faster than the RX 7600, and that trend is followed down to both of the low frame metrics. 140 frames per second works out to be 1 frame every 7.14 milliseconds, while 134 FPS is a painfully slow 7.46. I'll let the real gamers sound off in the comments below about how they can easily spot a 0.3 millisecond difference in individual frame times. Make sure to congratulate them on their amazing accomplishments. Spiderman Remastered also ended in a deadlock, again with the RTX 4060 taking the ever so slight but not really victory, with an average of 94 frames per second versus 92 FPS on the RX 7600. But things really get interesting when you enable FSR 2.0. While both GPUs support the feature out of the box, it's Team Red that shines here, managing 122 FPS on average with a low of 48. That's a full 32% increase over leaving FSR disabled, and 22% faster than nVidia's performance with it turned on. Overall, the game looks spectacular either way, so I say, why would any true believer leave performance on the table? Tiny Tina is a game that struggles when pushed to the brink, and consistently stutters between hipfire and scope view. As such, any performance gains over rasterized performance alone are going to be very welcome. With all settings at high, the RTX 4060 pulls out the victory with an average of 85 frames per second, or around 8% faster than the RX 7600. The AMD GPU performed well below where I expected when it comes to the 1% lows as well, managing only 26 frames per second. Enabling FSR 2.0 dramatically improved both cards, but unlike Spider-Man, the benefit was entirely in favor of Team Green here. With an average of 165 frames per second and a much improved 1% low of 93, the game goes from playable but with some issues to a solidly enjoyable experience. Oh, Cyberpunk, why can't I quit benchmarking you? Well, nearly every game on this list today was acceptable, even without DLSS or FSR enabled. There was no such luck on the streets of Night City. Of course, this was at the RTX medium preset, but I was still hoping for a better result. Surprisingly, it was the RX 7600 with the impressive victory, so long as you only check percentage points. An average of 34 FPS doesn't exactly have me planning my next game night around it. With DLSS enabled, the RTX 4060 does climb into the playable performance level, falling just shy of 60 FPS on average, but a manageable low of 40 FPS. The same cannot be said for AMD though. With FSR 2.0 enabled, we see frame rates climb only a couple points each, and not nearly enough to make the game enjoyable. Turning down the rasterized rendering settings in the game can definitely make for a great experience, but I wanted at least one title to show that ultra settings should be reserved for cards with actual horsepower, not just DLSS and dreams. Jedi Survivor is a game that relies heavily on graphics and storytelling instead of Twitch reaction gameplay, and I'm sure some will be disappointed that I don't have the same strong language for it as I did for Cyberpunk. But an average of 40 FPS and a low of 23 didn't feel nearly as bad as it sounds when I say it out loud. Game interactions rely on timing, not necessarily reactions to enemy fire or movement. Enabling FSR 2 is definitely recommended though, as both GPUs shot up from the low 40s to the mid to high 70s in average frame rates. Lows are still fairly low, but there's really no discerning the RTX 4060 from the RX 7600 in these results. In fact, every metric between these two cards in the game were within 5%, so it really doesn't matter which GPU you choose here. Saving the most interesting result for last, Red Dead Redemption 2 runs amazingly well on both GPUs, with an average of 70 FPS and a 0.1% low of 51, plus or minus 1 or 2 FPS depending on which card you actually look at. That type of consistency is much more important to me when playing games than high average frame rates, but lows that are distracting when they hit. Enabling DLSS, the nVidia RTX 4060 shoots into the lead with a very impressive 125 FPS on average, crushing the RX 7600's result with FSR enabled of just 90. But here's where things get really curious. With DLSS, the 4060 saw little to no improvement in low frame rates, in fact scoring lower than with it turned off. And keeping things interesting, the RX 7600 lows climbed to 70 and 59 FPS respectively, netting us the most consistent frame rates between the four results. Stacking the RTX 4060 against its closest competitor, the RX 7600, the nVidia card does seem to have a slight advantage overall, but it's definitely not much based on the titles that I tested today. Excluding the 52% disparity when testing ray tracing enabled in Cyberpunk 2077, its largest wins are in Doom Eternal and Tiny Tina, with just 13 and 8% victories respectively. Of the 7 games and 12 different tests that I ran, 5 of them resulted in de facto ties, including both DLSS and FSR trading blows depending on the title. The introduction of new rendering technology like ray tracing, DLSS, and FSR have definitely made benchmarking more difficult, especially with dynamic quality adjustments, sub-rendering, or any number of API-specific enhancements. It's taken away much of the objectivity the review industry has tried so desperately to achieve over the last decade and a half. And therein lies a lot of the problem that I see with reviews as of late. And full transparency, I've never fully agreed with benchmarking low-end GPUs with the fastest CPUs available as the definitive answer to performance's biggest questions. While it provides perfect metrics for comparing products between product stacks, it also doesn't help the consumer pick a GPU to put into their system that matches their budget. If every GPU that nVidia or AMD produce is dog shit according to your own metrics, it might be time to rethink the way we review graphics cards. The answer can't be to avoid buying anything new and to only look for fire sales of previous generation cards. Without talking to a single other reviewer, I'm guessing that the RX 6700 XT is going to be mentioned multiple times, with honorable mention going to a used 2080 Ti or even an Intel A770 8GB. Now here's where all of this comes full circle. As a reviewer, I understand we can fill a number of different roles in this industry. I understand the role of making sure NVIDIA, AMD, Intel, etc. knows that we're on to their misdeeds and mistruths, and we can hold them accountable for skimping on lower-end hardware in an effort to force consumers to upgrade to the next product in their stack. Let's take a step back for a second. For all the truth in that previous statement, that's also kind of NVIDIA's job as a business, isn't it? You can't go to a car dealership looking for a Corolla without realizing that a well-equipped Corolla is only a couple $1,000s less than a well-equipped Camry. Product stacks are often designed to make you think, it's not much more money, why don't I upgrade? I'm worth it after all, and if I'm only going to be buying this one graphics card or this one car for the next 5 years, I might as well get the best one that I can afford, right? And to be honest, there's nothing inherently wrong with companies doing that. Hell, remember when Intel was putting price gaps between i5s and i7 CPUs, with hyper-threading only being available on the i7? What about Apple making their top-spec 13-inch laptop half as fast as the bottom-end 15-inch, while also costing more? Craft Computing remembers. So, NVIDIA doesn't care about you. Neither does Intel, AMD, Asus, Gigabyte, Apple. And there's nothing groundbreaking about that statement. Yet in every GPU review, it's said like it's some new revelation. So why is it today that reviewers think there's such a disparity between the top end and the bottom end of graphics cards? What caused this rift? Honestly, it's kind of NVIDIA's own fault, and for that we need to go back in time a little ways. 7 years ago, when NVIDIA launched their Pascal series of GPUs, you can get a GTX 1060 6GB for $299 MSRP. A 1078 gig was $399, and the flagship 1080 launched at $599. Making arguments for and against each GPU was pretty easy. The 1080 performed about 60% faster than its little brother, and didn't have pesky things like rays or DLSS to muck up any objective measurements. And you got 60% more performance for about double the money. Now, instead of $300 between the flagship GPU and its more affordable, if not slower kin, the difference is over $1,000, with the 4080 and 4090 easily doubling up and oftentimes more the frame rates of the 4060. But are we really getting less than what we did for $299 when that GTX 1060 launched? Or have our expectations of how mid-range GPUs should perform compared to those higher-end offerings been skewed by even higher-end offerings? What would our perception of this entire situation be if the RTX 4090 and 3090 just never existed? Let's call them Titans, as that seems like an appropriate moniker given their godlike price points. And just follow me here. Why don't we slide each GPU up by one place? As reviewers have previously mentioned, it seemed like NVIDIA was shifting 80 series cards to 70 series names to help raise the perceived value of those higher-end SKUs. What we're left with is a product stack that doesn't feel that far removed from the Pascal lineup we all want NVIDIA to return to. At the top, we would have the RTX 4080, an $800 card with 7,680 CUDA cores and 12 gigabytes of memory. Up next would be the 4070 Ti at $599, coming in with the same 12 gigabytes of memory, 76% of the CUDA cores, but also only 75% of that price. Next up, the 4070 at $499, an odd choice of 16 gigabytes of memory and a little bit lacking of CUDA cores, if I'm being honest, at 4,352. But again, specs and price line up at 56% of the performance and about 62% of the cost. The new 4060 Ti would come in at $399 with 8 gigabytes of memory and the same number of CUDA cores as its bigger brother, and this seems to be where the performance would be the winner compared to its price point. While it would have half the amount of RAM, that shouldn't hurt if you enable NVIDIA's latest DLSS, and you get almost the same performance as the 4070, but for a full 20% less money. And finally, we land right back where we started at the current RTX 4060, which lines up exactly with previous generation 60 series cards in terms of price, assuming we ignore the previous two generations with the whole global pandemic, crypto craze, and silicon shortage that preceded it. 3,072 CUDA cores doesn't sound all that sexy, especially compared to the 7,680 of the new flagship card. The GTX 1060 had 1,280 CUDA cores compared to the 2,560 of the GTX 1080. So instead of half the CUDA cores, we're now getting only a measly 40% of the performance potential? Well, also consider the GTX 1080 had a retail price of $599 at launch versus my version of the RTX 4080, which is placed at $799. Suddenly it starts to sound a little more reasonable, doesn't it? Look, I'm not sitting here trying to apologize on behalf of nVidia or AMD or anyone else in this industry, but I've also spent my entire adult life in the PC industry in some capacity, and to be honest, I'm not seeing what all the fuss is about if you simply start calling the products by the names they used to have or ignoring the names entirely and just judging them based on the product that's delivered. We in the media had hunches that with the 3000 series, nVidia was attempting to shift their product names higher to add more mystique around their flagship parts, and eliminating the Titan lineup was part of that plan. And before you go off about how nVidia never had consumer cards with 4 times the CUDA core count as a 60 series GPU, you're correct, but they did have those cards in Enterprise, so you'll forgive my feigned outrage at not being given the Kepler-based Titan Ti Super back in 2014 that I always wanted. Hardware reviews are getting more and more difficult to sum up with a nice and neat objective number that attempts to tell the entire story. And again, I'm not to say that any of the reviewers I mentioned are wrong in their evaluations of the RTX 4060. I avoid drama like the plague, and here I am at 6:38 in the morning stirring up a whole potential pot of it. But I feel nuance in hardware reviews is a bit of a lost art, as building a PC is filled with nothing but potential performance variables. Some people prefer small form factor PCs, others want dead silence, still more want water-cooled beasts that can spin a power meter like a top, and others just want to play games without worrying if they're getting 59 FPS instead of 60. So, how do we wrap this up? If you're looking to buy a graphics card today, and if you're looking to spend $300 on something brand new with a warranty, your options are pretty solid between the RTX 4060 and the AMD RX 7600. Both have some strengths and some weaknesses, especially when it comes to some of the newer tech like ray tracing or AI sub-rendering. But at this price, you're sure to get solid performance with either card. Just make sure to spend some time fine-tuning some of your settings in games. A couple more days, and I guarantee I'd have almost every single game on this machine running at about 100 FPS on average, and I wouldn't have to take a second mortgage out on my house to do it either. If you're interested in either the RTX 4060 Accelerate from PNY or the RX 7600 from XFX, or any of the other parts that I mentioned in today's video, I'll make sure to have affiliate links down in the video description. Go give those a look. On your way down there, make sure to drop this video a like and subscribe to Craft Computing if you haven't done so already. And man, do I ever hesitate to say leave me a comment and let me know what you thought of this one. Follow me on the social medias at Craft Computing, and if you like the content you see on this channel and want to help support me in what I do, consider joining the Patreon or heading on over to craftcomputing.store, grabbing yourself one of our snazzy new pint glasses, and start drinking like a pro. That's going to do it for me in this one. Thank you all so much for watching, and as always, I will see you in the next video. Cheers, guys. Things are going to get awkward at LTX. Today's beverage is from Zentopia. It is their Huckleberry Lemonade, sparkling lemonade infused with 50 milligrams of CBD. This one is from Eugene, Oregon. Why no beer? Because it's 6 in the morning. I got my drivers 36 hours ago. Let's do this.